Hello and welcome to Crazy Math Productions. Today we're going to be looking at solving graphing one variable inequalities. We're also going to look at translating from words into expressions, more specifically into inequalities. Let's go ahead and get a start. First thing I want to do is go ahead and mention when you're going to be graphing these, number one, you need to know which one translates into what kind of a point on the graph. Now, if you'll write the greater than or equal to, less than or equal to symbols, notice it almost looks like a little face. It gives you a closed dot. And if you write the greater than or less than signs, it gives you an open point. Now, when you're graphing this, for example, let's look at number one. Let's go ahead and graph. We're going to graph, let's see, I like to do -5 in the middle, and 6, 7, 8, 9, 10, 4, 3, 2, 1, 0. And what I like to do is to go ahead and put my, since it's or equal to, that's going to be a closed dot. And you can notice that the symbol here, greater than or equal to, that greater than matches this arrow here. I'm going to put it another color so you can see it a little more clearly. This matches this. So we're going to shade to the right here. Now, that's just sort of a stupid way to remember it. This only works when the variable's on the left-hand side. You may have to switch that if the variable were not on the left-hand side. Now, that's sort of how to do it. But why does it work that way? Well, we're looking at solutions here, and there's going to be an infinite number of them. For example, what's greater than or equal to -5? Well, -4 is -4.5. If you plug in, for example, -4, -4 is greater than or equal to -5. And if you notice, if you actually drew your hand, if you put your hands up, it's more like a duck, but anyway, your left hand matches this symbol. So on the number line, it's to the left. Your right hand matches this symbol, which is greater than. Now you notice this almost looks like an L for less than. It's also your left hand. All of those with that same left hand symbol. This one is definitely not an L. That's greater than. And that's your right hand. So if you hold up your right hand, that actually fits. Yeah. Let's see if I can, nope. Excuse me. If you hold up your right hand, that fits this symbol, which is greater than, so it's actually going to go to this side as well. So you notice, what symbol is it? Well, hold up your right hand. Does not make an L with your right hand, so that's greater than symbol. And if you hold up, again, variables on the left, so you can hold up your right hand and it's going to fit this curvature of your right hand. Now, which one, is it closed or open dot? How do you remember it, and what does it mean? Well, again, the purpose of this, anything that's shaded here, for example, I could shade it in a different color. It doesn't matter, but so you know what I'm shading here. Everything that I've shaded, if I plug that into the inequality, it makes it true, which is the whole point of this. So if I plug in a -5, -5 is greater than or equal to -5. That's true. -5 It's not greater than, but it is equal to. That's why you have the or equal to here. So negative 5 is greater than or equal to negative 5. That's why we fill in the dot, fill in the point there. This is filled in. That means negative 5 works. Everything that is shaded, including the closed dot here, everything that's shaded makes this a true statement. Now, how can you remember which one? Well, if you notice, when we put these, they sort of look like little faces. And you can think of these as sort of the wrinkles, like an old man. Now, you can usually tell an old man is usually a wise man. He knows when to keep his mouth shut, whereas a young man, he will just open his mouth and anything comes out, and a lot of times he's going to regret what he just said. Will speak out of anger and just say very rash things. So you can make the little face up at the top, old man with the wrinkles. He knows when to keep his mouth shut. But a young man, man, he'll just say whatever he wants to. So maybe one way that you can remember it. Anyway, back to, I think I'll keep the left and right hands ready to go. Okay, having said all that, let's go ahead and get back to business. Look at number 2. There are 2 things that make me switch this inequality symbol. What do I mean by switch? Well, for example, x minus 2 is greater than 5. If I want to switch the 2 sides, I want to put x minus 2 on the right-hand side and 5 on the left-hand side, I've got to change it from greater than to less than. That's the first reason I would need to switch the sign. The second reason is if I multiply or divide by a negative. So, for example, let's see, number 4. When I divide by negative 6, I must switch the inequality symbol. Well, what's the reason for that? Well, again, we're trying to graph these solutions. So when I graph the solution set, I can actually do trial and error and graph the solutions before. If I divide by negative and I don't switch the sign, it actually switches the solution set. And that's bad. We want to preserve the solution set that was already there. So basically, long story short, make sure you switch the sign so that you keep the same solution set. All the numbers that worked before you divided by a negative or multiplied by a negative still work. So let's look at number 2 again. Okay. X minus 2 is greater than 5. Well, if this were an equals sign, then we would simply just add 2 to both sides. We would get x is greater than 7. And that's what we do here as well. X is greater than 7. The variable is on the left-hand side, so our trick will work. I'm going to go ahead and the 2 multiples of 5 closest to 7 would be 5 and 10. So all I'm going to do is just list 5 and 10. That was terrible. Try that again. There we go. All right, so 5 to 10. We have 7, so 5, 6, 7. Now, is it going to be an open or a closed point? Well, look at this is going to be the young man because he doesn't have a little wrinkle underneath. So that's going to be, he's going to have his mouth wide open, say anything he wants to. So also you could think of 7 is greater than 7. Is that true? No, it's not. So do not include that point. Either way, it's going to be an open point. Which way do I shade? Well, the variable's on the left, so our trick should work. You'll notice that if you hold up the left hand, no, that doesn't match. If you hold up the right hand, that does match. So we need to go this direction. Again, if the left hand had worked, we would have gone this direction. X is greater than 7, so we're going to go this way, to the right. And there we go. Solve. Graph. Let's look at number 3. Okay, x plus 1/3 is greater than or equal to negative 5. We're going to subtract negative 1/3 from both sides. X is greater than or equal to. Now, negative 5 minus 1/3, they're both negative, so they're going to join, and we're going to get negative 5 and 1/3. Now, you could change 5 over 1 to negative 15/3. Negative 15/3 plus negative 1/3 would be negative 16/3, and transfer that back into a mixed number form. Either way, we get x is greater than or equal to negative 5 and 1/3. So for number 3 here, you've got two options. The first option is to simply say negative 5, 0, and negative 10. And just sort of guess. Negative 4, negative 5, negative 6, it's going to be between, so it's going to be right here. The other way you could possibly do it is just say negative 5 and negative 6, and literally have two hash marks between, so that we have negative 5 and 1/3, negative 5 and 2/3, negative 5 and 3/3, which would be negative 6. And in that case, it would go right here. But we're just going to use this method for now. X is greater than or equal to negative 5 and 1/3. Now, is it a closed or open? It's the old man. He's got the wrinkle here. So it's a closed dot because the old man knows how to keep his mouth shut. Which way are we going to graph? Well, that doesn't work. This does. So it's the right hand because it's greater than. Remember, X has to be on the left for this trick to work. But right hand matches, we're going to go to the right. And of course, do not forget that the meaning of this is that negative 5 and 1/3, if I plug it in, makes the statement true. So that's why it's filled in. That's the meaning. If I plug in negative 5, negative 4, negative 3, any of these real numbers between, irrational or rational, all of them will plug in for x and make it a true statement, which is why I'm shading all of these. There's an uncountably infinite number of solutions that I can plug in. Okay, look at number 4. Now we're changing gears here a little bit. I'm going to divide by negative 6, and whoa, I've got to change signs. Don't forget that you have to switch x. I'm going to switch the sign. Be careful, very careful here. X is greater than or equal to negative divided by negative is a positive 4. So when I divide by a negative, whoa, watch out what happens when I divide by a negative. The sign switches. Be careful there. Alrighty, so positive 4, the nearest multiples of 5 are 0 and 5, just on either side. Again, you don't have to do that, but it's just a very convenient method for graphing. Alright, so x is greater than or equal to 4, so we're going to place our point on 4. And you notice this is the old man, he's got the wrinkle. So old man knows how to keep his mouth shut. And let's figure out which way we're going to graph this. Left hand, nope, that does not match. Right hand, that does match. So we're going to the right. And there we go. Number 5. I have to clear a little bit of room here. Number 5, 5a minus 6 is greater than or equal to 3a. Well, if you followed Crazy Math Productions, you remember that we have a little Elvis song that goes with this. First distribute, which we don't have. Then combine all of your like terms. Now that's assuming on the left-hand side or the right-hand side, which that does not work. Please remember keep, change, change, or you will get burned. So we're going to keep, change, change there. Again, some folks do not like that, and I completely understand. But for our purposes, for Crazy Math Productions purposes, we will keep, change, change. Then get all your variables onto the same side. Well, that's the essential step here. You can choose either 3a or 5a. It doesn't matter which one. We're going to get rid of it by adding its opposites. We're going to add negative 3a to both sides. 5a plus negative 3a is 2a. It's going to be 0. And we're going to add the, then get all your variables onto the same side. First addition or subtraction. Then multiply, divide. And be careful. Are we dividing by a negative? In other words, is the number with the variable a negative? Well, no, it's not. These numbers here that I've divided both sides by, those are not a negative. So I did not have to switch the inequality symbol. As it were, 2 divided by 2 is 1. 1a is just a. And a is greater than or equal to positive 3. So let's graph this. The nearest multiples of 5 are 0 and positive 5. Again, I just try to find a multiple of 5 on either side of the 3. 1, 2, 3, 4, 5. Okay, and we're going to put our point at 3. So 1, 2, 3. Now, this is an old man because he has the wrinkle under his eye. An old man knows how to keep his mouth shut. And which hand is going to match? The variables on the left. Remember, if it's not on the left, we have to switch the sides. What do you mean by switch sides? I mean put the 3 on the left side, the a on the other side, switch it. Again, I don't want to do that here because now the variable's on the wrong side for the trick to work, for the hand trick to work. So don't do that. But if the variable are on the right side, you would need to switch it so that it's on the left side. All right. Now, looking at my inequality symbol here, to the left, no. To the right, yes. So variables on the left, now we're going to the right, shading to the right. And there we go. Don't forget the meaning here. This means that if I plug in a 3, this is true. 3 is greater than or equal to 3. 4, 5, all of those are greater than or equal to 3. And of course, any real number, rational or irrational as well. An uncountably infinite number of them. Let's go ahead and clear the screen. We're on number 6. Okay, so number 6. We have negative 5y minus 34 is greater than or equal to negative 19. We want to solve for y, so first distribute, nope. Then combine all of your like terms, no. Please remember key change, which is absolutely optional. You don't have to do that at all. Or you will get burned. Then get all your variables onto the same side. Well, it's on the same side. First addition or subtraction. Then multiply, divide. Whoa, watch out, because we divided by a negative, we have to switch the sign. So watch out when you divide or multiply both sides by a negative. I'm looking at these numbers here, or the easiest way is to see if it's with the variable on the same side with the variable. So y is less than or equal to negative 3. Now the variables is on the left, that's what we want. So negative 3, the closest multiples of 5 are 0 and negative 5. Oh, that was not a very good job. That's a little better. So we're going to put our point as far as graphing it. This is the solve part. End up with y is less than or equal to negative 3. And graphing it, we're going to put it on 0, negative 1, negative 2, negative 3. Now, this is an old man because he has the or equal to. So it's going old man knows how to keep his mouth shut. Also, variables on the left, so that doesn't work. Right hand is not good. Let's see. Left hand, yes, that does work. Notice. Okay, it's not wanting me to do it. Notice that does work left hand, so we're going to shade to the left. And last but not least, number 7 here for this section, 5 minus 8y is greater than or equal to 23. Now, please be careful with this. You cannot commute subtraction. What I mean is, you cannot do this. Do not do that. You may keep change, is the algebraic definition of subtraction, and then switch them. That is perfectly legal. But do not try to commute and say that this is somehow a positive 8y. It is not. It is not. Okay, so we keep change. We're going to use commuter property of addition. And now we're going to solve. So first distribute. Nope. Then combine all of your like terms. No. Please remember key change or you'll get burned. No. Then get all your variables onto the same side, which it already is. First addition or subtraction. Then multiply, divide. Whoa, we got to divide by a negative, so we switch the sign. Now 18/8, we're going to reduce this down to negative 9/4. And for the sake of clarity here, we're going to make it a mixed number, which is negative 2 and 1/4. Again, top dog in the house. 4 is the divisor here. 4 goes into 9 2 times. 2 times 4, 8. Subtract, we get 1, and the remainder goes over the divisor, 2 and 1/4. So that's how we get the 2 and 1/4 there. Of course, don't forget the negative sign here. Okay, so let's graph number 7. Negative 2 and 1/4. Now, let's try the second method that we had mentioned. I'm actually going to go negative 2 and negative 3. I can say negative 2 and 1/4, negative 2 and 2/4, negative 3 and, negative 2 and 3/4, and negative 2 and 4/4, which is negative 3. So we split it into 1, 2, 3, 4 sections, and now we're going to put our point on negative 2 and 1/4. Now, open or closed, well, this is the old man. He's got the wrinkles, and he knows how to keep his mouth shut. So we're going to close this dot. The variable's on the left-hand side, so that's good. So we're going to shade it to the left. And we're good to go. Why did we shade to the left? Well, you notice that the left hand matches that, so we're going to shade to the left. Left hand. All right, and now we simply need to translate into an inequality. Three is less than. Well, number 1, 3. When they say is, be careful. The word is itself means equals. Less than itself means subtraction. But if they say is less than together, then suddenly it's the is less than an inequality. So when they combine those two together, we're dealing with an inequality. So be careful there. So 3 is less than a number y. That's my inequality, as simple as that. Number 2, 5 and 1/2 is greater than a number k. Number 3, a number h is at least. Now be careful with is at least and is at most. They're actually the opposite of what you would think. So is at least, you might want to put an important, just tell yourself that this is very important, is at least. That's actually greater than or equal to. Because if it's, let's say that I say I am at least 25 years of age, well, I could be 25 years, I could be 26, 27. I'm at least 25, so I'm greater than or equal to that. It's actually the opposite of what you would think it would be. Also, is at most. That would actually be less than or equal to. So be careful with those two particular phrases. Number H is at least, so that's actually greater than or equal to 4 3/4. Number 4, number J, is at most. Well, be careful, less than or equal to. Number 5, a number. So we could use any variable there we want. I could use x, just very familiar. So a number is greater than or equal to. So is greater than or equal to 0. Number 6, 7 less than. Now when you see that word than, usually that's a switch word. So instead of putting the 7 first, I'm going to put it at the end and use subtraction. 7 less than a number, so say x, is less than 5. So be careful. When you see that word than, usually that's a switch word. Than, from, and into are my traditional switch words. Than, from, into. And of course, you have to be careful using just cookie cutter approach. But traditionally, if you see than, less than, fewer than, from, and into, those generally tend to throw students off. Traditionally, they are a situation where you'll switch the two. Let's look at number 7. 2 more than. So again, same situation. Now, since it's more than, that's an addition situation. I don't necessarily have to switch them, but I'll go ahead because that's just a good protocol to use with the switch words. So 2 more than a number. So we're going to put the number first and the 2 at the end. Again, than being a switch word. 2 more than a number, x plus 2, is greater than 9. Number 8, twice. Twice, that's 2 times. You can see the root word 2 in twice. 2 times. 2 times a number, so maybe x is greater than. So we've got that is and then the greater than together. Greater than means addition, is means equals, but when they combine together, is greater than is the inequality symbol. And then 12. Number 9, half. You could treat half two ways. It could be something divided by 2, or it could be 1/2 times. So half could be, say, x divided by 2, or it could be 1/2 times x, something like that. Either way would work. So half a number, 1/2 times, since they say a number, we get to pick x, y, q, theta, whatever. Let's use y this time. So half a number, 1/2 times y. Again, we could also say y divided by 2. It doesn't matter. Is less than. So is less than. Oops, or equal to. I did not see that. So is less than or equal to 6. 3 more than. So that word than, we're going to switch. We're going to put the 3 at the end and whatever else at the beginning here. 1/3 of a number, so we're going to do 1/3 of, meaning multiplication, a number, so x. All of this is less than 9. Okay, 18 is greater than or equal to. Well, that's phrased together. So 18 is greater than or equal to, a lot of words for one symbol, 4 less than. Now, be careful with the than, we're going to have to switch. So we know we're dealing with subtraction here, but instead of the 4 being at the beginning, the 4 is going to be at the end. 4 less than twice, again, 2 times a number. We could use x, y, whatever you'd like there. Okay, number 12, just so I have enough room, I'm going to move down here. 4 more than, so we're going to add, and we're going to use a switch. So the 4 goes at the end, the whatever else next, it goes at the beginning. So 4 more than, switch, twice, 2 times a number, say x, is less than the opposite of a number. That's interesting. So I'm going to take some kind of a number that's the same number that I'd used earlier. So if you've used x before, we have to use x again. To get the opposite, I'm going to have to multiply by -1. And you could say -1 times, or you could just make it appear as what students usually call -x. Well, it's not really -x. It depends on what x is. We don't know. But it's going to be certainly the opposite of whatever x turns out to be. So either version will work, but this is probably the better version. Okay, number 13, let's move down here. 2 more than, switch, and more than is addition. 3 times a number, so say x, is at most, be careful, remember looking up here, at most and at least, they're the opposite of what you would think. So is at most is actually less than or equal to the number 11. Number 14. 5 less than, again, that's a switch word. A third of a number, so a third times, say, x. You could also say x divided by 3. Both of those are equally correct. Is at most, so again, you would think most, bigger, greater than, but it's not. Is at most, it's actually less than or equal to, and then the number 15. Okay, and just a general overview here. Folks, for this section, if you're looking through, if you see the greater than or equal to, less than or equal to, again, that's a closed point, because when you plug them in, they work. You know, the old man with the little wrinkles knows when to keep his mouth shut. The young man without the little wrinkles, without the or equal to, just tends to put his mouth open and just say whatever he wants. You look at the little hands, incredible hands, such wonderful artwork. Again, it makes an L, and that's the less than. That's not an L, so that's greater than. When you have less than and there's a variable on the left, it's going to go to the left. It's going to be shaded this way. If you have x on the left here, it's going to be shaded to the right. If you right hand, it's going to be shaded that direction. So just some things to keep in mind. I do hope that you go back through, pause the video where you need to, and then replay as necessary and try and make sure you've gotten these correct. Thank you so much for listening to Crazy Math Productions.